Welcome to the Fund Zone Support Aid guidance video for Task 3. Refer to the Facilitator's Guide for talking points and purposeful questions related to each component of the task. The overall goals of Task 3 are to look for patterns to develop fluency with the foundational fact sets of 0 and 1, and to apply multiplication properties and doubling as strategies to efficiently multiply by 4. Here are the materials you will need for this task. The task launch of Task 3 focuses on introducing the foundational multiplication facts for 1 and 0. Students will explore patterns within these facts and recognize how they demonstrate the identity property and the zero property. These properties will be identified as efficient strategies for multiplying by 1 and 0. Here's an example of how you can facilitate this. Let's get out our square inch tiles. Build an area model with one row of 5 tiles. What is the area of this model? How many tiles did it take to build this model? It took 5 tiles to build this model, so the area is 5 square inches. What multiplication equation represents this model? 1 row of 5 tiles is the same as 5 square inches. Let's fill this in on our table. 1 row, 5 tiles per row, is an area of 5. Next, let's build 8 rows of 1 tile. How many tiles did it take to build this model? What is the area of this model? It took 8 tiles to build this model, so the area is 8 square inches. What multiplication equation represents this model? 8 rows of 1 tile is the same as 8 square inches. Let's fill this in on our table. 8 rows of 1 tile gives an area of 8. Next, build an area model with 1 row of 4 tiles. What is the area of this model? The area is 4 square inches. Let's write a multiplication equation to represent our model. 1 row of 4 tiles is the same as 4 square inches. Let's fill this in on our table. Next, let's build an area model with 15 rows of 1 tile. What is the area of this model? The area is 15 square inches. The multiplication equation that represents this model is 15 rows of 1 tile per row is the same as 15 square inches. Let's add this to our table. 15 rows, 1 tile per row, gives us an area of 15. Look at our multiplication equations and the information in the chart. What do you notice? We can see that if one is a factor of the equation, then the area is equal to the other factor. This is called the identity property. Let's complete our project notes for multiplying by 1. At the top, we see the definition for the identity property of multiplication. This property states that the product of any number multiplied by 1 will remain the same value. We will begin by drawing a model for one group of 9. Let's draw what this could look like. If I have one group of 9, I simply have all 9 objects in one group. Therefore, my total is 9. Now let's look at 3 groups of 1. Let's draw a model for this. We should have 3 circles of 1 each. This gives us a total of 3. Next, let's look at this for one group of 120. We shouldn't panic at the value of 120 because we simply know that we have one group of 120, so our model looks like this. So our total is 120. Lastly, I would like for you to draw your own model for any number multiplied by 1. When you have completed this, share your model with your neighbor. Now let's move our focus to multiplying by 0. I would like for you to build an area model with 0 rows of 5 tiles. I've noticed that no one is building a model. Why is this the case? It is not possible to build 0 rows of 5 tiles. Because if we have 0 rows, then we have nothing. Therefore, 0 rows of 5 tiles per row is equal to an area of 0. Let's look at this as a multiplication equation. 0 rows of 5 tiles is equal to 0 square inches. Now I would like for you to think about how we could build a model for 8 rows of 0 tiles. Once again, we notice we cannot have 8 rows of 0 tiles. Therefore, the area would be 0. The multiplication equation for this is 8 rows of 0 is equal to an area of 0. Let's try one more. What if I asked you to build an area model for 0 rows of 1,873 tiles? How many tiles would it take to build this model? Once again, it would take 0 tiles because we have 0 rows. The multiplication equation for this looks like 0 rows of 1,873 tiles is the same as an area of 0. Look at our multiplication equations and the information in the chart. What do you notice? We can see that if 0 is a factor of the equation, then the area will always equal 0 because we cannot have 0 rows of a number or a number of rows with 0 tiles in them. This is called the 0 property of multiplication. Let's complete our project notes for multiplying by 0. When multiplying by 0, think of the 0 property of multiplication. The 0 property states that the product of any number multiplied by 0 will be equal to 0. Let's look at the two models. The first model shows 6 groups of 0. We can draw this as 6 circles with 0 in each circle. As we see, the total is still 0. We can't draw a model for this because there are 0 groups. Therefore, there's nothing to draw. Let's multiply 4 different numbers by 0. Let's look at 7 groups of 0. Can we draw this model? We can, because we have 7 groups with nothing in them. Okay, so I have my 7 groups, 1, 2, 3, 4, 5, 6, 7. Each group has 0 in it, so I know I have a total of 0. Okay, next, let's look at 0 groups of 10. Can I draw a model for this? I can't, because there are 0 groups, and 0 groups cannot be drawn. So I know that if I have 0 groups of 10, I have 0 items. Okay, next let's think of 0 groups of 4,000. Can we draw this model? We can't because there are 0 groups, so we know that 0 groups of 4,000 is the same as 0. Lastly, I would like for you to draw a certain number of groups of 0 so that you can have a model. Draw your model and share this with a partner. To introduce the context, you will play the following video from Avery Jones.
Hey team, I'm very impressed with what you've done. Today I would like for you to figure out how many tiles it would take to cover the floor in Champions Cafe. Don't forget to show your work. I want to see a lot of details. Can't wait to see it.
Avery has asked the students to determine the number of tiles needed to cover the base plate of the Champions Cafe. On the blueprint, we clearly see the width of the model is 4 inches. Guide a group discussion on how students can use the information on the blueprint to determine that the length is 7 inches. Send students in groups of 2 to 4 to solve the task. While students are working, walk the room and make anecdotal notes about the strategies students are using. Listen and look for student groups that are counting all tiles, skip counting by rows or columns, or are using properties such as decomposing floor into 2 groups of 2. You will use this information to facilitate the task debrief. During the task debrief, you will select student groups to share how they found the total number of tiles. Here's an example progression of strategies. Start by having a group that counted all, then a group that skip counted by rows or columns, and lastly, a group that used the idea of doubles explored during task 1 to efficiently find the number of tiles. Guide students in noticing that they all arrived at 28 tiles. However, the group that used doubles as a strategy was the most efficient. You will now move to the whole group lesson component of the task. The goal of this lesson is to explore how to use the distributive property to efficiently find the area of a rectangle with a length of 4, building on their understanding of doubles facts. You will begin by letting students know they will now create the base plate for the Champions Cafe section of the Fun Zone model. Remind the students that they may choose the tile colors they prefer, but their model should reflect efficient counting strategies. Emphasize the importance of using color groupings that support efficient strategies rather than assigning a different color to every tile, which makes counting harder. Provide time for students to construct their models by gluing their chosen paper tiles onto cardstock. Remind students to determine the cost of their base plate using the tile price list. Select and share models that highlight efficient counting strategies. Record notes as a class on the Task Project Notes page. Here's an example of how to facilitate this. Let's complete our Task 3 project notes for multiplying by 4. We will use the distributive property of multiplication as a strategy for multiplying by 4. Let's build an area model for 2 times 3. We can use our double strategy to quickly know that 2 times 3 is 6 without having to count each individual tile. Let's build and connect a different 2 by 3 model. How many more tiles did we add to our model? 6 more tiles. We know that 2 groups of 6 is the same as 12. What do you notice is the length of our model? It is 4. What is the width of our model? It is 3. We can use doubles to help us efficiently calculate our multiplying by 4 products. Let's draw this in our notes. The multiplication problem that represents our model is 4 times 3. We can use the distributive property by decomposing our 4 into 2 plus 2. We can illustrate this by showing 2 rows of 3 within our model. So in this case, I distribute my 2's to my 3. I have 1 2 by 3 plus another 2 by 3 as illustrated in our model. Then I know that I have a total of 12. So I can use 2's to help me quickly calculate the product of my times 4 facts. Let's look at 4 times 6. Where could we decompose the model to get 2 groups? We can decompose the width of 4 into 2 rows. So we have 2 rows of 6 and 2 rows of 6. What do we know the double of 6 is? 12. So if we double 12, we get 24. Okay, 6 doubled is 12, and 12 doubled is 24. So I'm simply just doubling the number and multiplying by 4 twice. Let's do this for 4 times 8. We will draw an open area model as we do not have a gridded section. I have 4 rows of 8. We can decompose the 4 into 2 and 2. What do we know the double of 8 is? It's 16. So 16 doubled is 32. So we said 2 times 8 equals 16, plus another 2 times 8 is equal to 16, for a total of 32. Now I would like for you to try this strategy on your own. Multiply any number by 4 by decomposing the 4 into 2 plus 2. After the mini lesson, have students complete the formative assessment slip. You will use the results from this to plan small group instruction during the menu portion of the task. Sort the work into 3 groups: proficient, marginal, and needs support. Here's an example of work that demonstrates a need of support. Although the student is accurate, the student is still counting all tiles. The goal of the unit is to move beyond counting all. Here's an example of work that demonstrates marginal understanding. Although the student is beyond counting all, the student is still relying on a counting strategy to multiply. Here's an example of work that demonstrates proficiency. The student has decomposed the model into 2 sets of doubles and demonstrates a strategy beyond counting. Next, it is time for Math Menu. During this time, students can choose to work independently, with a partner, or with a group to complete tasks on the menu board. You will pull small groups and differentiate your instruction based on the information from the formative assessment. The goal of small group instruction is to move students to more efficient methods of solving times 4 facts. Focus on using the foundational fact of doubles as a strategy for multiplying by 4. For students that demonstrate a need of support, you will build area models with clearly defined rows and columns. Move students to recognize equal groups by skip counting by the number of tiles per row. Use a sheet of paper to isolate one row at a time to count efficiently. Compare the efficiency to counting by ones. Then, have students compare models for doubles and times 4 facts, highlighting where the double is within the times 4 fact. For example, build a 2x3 model, then compare it to a 4x3 model. For students that demonstrate marginal understanding, you will build area models and connect skip counting to the idea of grouping rows in sets of 2. For example, in a 4x6, count 2 rows of 6 at a time rather than 1 row of 6 each time. You will connect the concrete model to a visual representation on grid paper. Then color the groupings of 2 rows in different colors. You will also build and draw models and connect these models to equations. Connect that 4 times 6 is the same as 2 rows of 6 plus 2 rows of 6. For students that demonstrate proficiency, you will explore alternate decompositions of 4 and discuss efficiency of using the foundational fact of doubles to another decomposition. You will introduce equations such as 4 times 6 is the same as 2 times 6 plus 2 times 6, and have students build or draw area models to represent the equation. Have students invent their own 4-row tile models and write 2 equations to represent different strategies. Have students choose the most efficient strategy. With each small group, guide all student groups in creating area model flashcards to build fluency with multiplying by 4 using efficient strategies. This activity is based on Graham Fletcher's array cards. First, focus on 4 times 7. Review efficient strategies from the mini lesson, and use colors to shade the card, highlighting the use of doubles. Complete a few more cards as a small group and then release the students to complete their set with a partner. The goal is to connect concrete models to visual representations and to reinforce the use of doubles and the distributive property as efficient multiplication strategies. While you are working with small groups, students will have the option to play the games, the game of pig, and race to 100. Here are the directions for each game. The goal of the game of pig is to be the first player to reach a total sum of 100 points. Players will need a pair of dice, blank paper for recording, and at least 2 to 3 players. So the first player starts the round by rolling the dice, and then they add the 2 dice together. So in this case, 4 and 2 is 6. The player can decide to continue to roll and add to that total, or they can decide to stop there and keep those points for the round. So for this round, I'm going to stop there, and so my total points I have for this round are 6. Okay, so player 2 is now going to go. They roll the dice, they get 12, they're going to roll again. Okay, they get 8, so 12 and 8 makes 20, and they decide they're going to stop there, and they have a total of 20 points for the round. Now we start round 2. So I will go again. All right, I get 12. I'm going to be a little bit more brave this time and continue to roll. Okay, so this time I got 5. However, if you see here, I rolled a 1. And our directions tell us if I roll a 1 on any of the dice, my turn ends and I get 0 points for that round. So my round total is 0. I still have 6 points from round 1. So now player 2 is going to go again. They start off with 12. And they roll a 1. So they get a 0 and they still have 20 points for round 2. Okay, for round 3, I roll, I get a 12. I roll, I get 8, so I'm at 20. I get 12, so I'm at 32. I get 5 more, so I'm at 37. I roll 12, so I am now at 49. I'm going to try one more time. Okay, and so I'm at 49, and I get to add 6. So now I have a total of 55 points. I'm going to stop there, and I add it to my 6 from before, so I have 61 points after round 3. All right, let's let player 2 go. All right, player 2 rolls a 12, another 12 for 24. So now player 2 has rolled double 1s, and what happens with double 1s is not only do you get a round total of 0, but you've lost all your other points. So now player 2 has a total of 0 points, and I have a total of 61. So in this game, my partner and I would continue to play rounds until one of us reaches a total sum of 100. This game provides students a chance to practice addition fluency strategies while also providing a real-world probability experience. In the game Race to 100, players will need 2 dice, 1 game board, and 1 game marker per player, and blank paper for recording. 2 to 4 players can play this game. To play the game, players will take turns rolling the 2 dice. Players may decide to find the sum, difference, product, or quotient of the 2 numbers rolled. The purpose of the game is to be the first player to reach 100. So early on in the game, you want a higher total, whereas later in the game, you may need to use smaller totals. So that determines which operation you will use. If a turn yields an answer over 100, the player loses a turn. Okay, so for this first roll, I get 3 and 3. So when I think about my different operations, I know that multiplying these two is going to give me the largest number. So 3 times 3 is 9. So I would take my game marker and place it on 9. Okay, so then my partner goes, and they roll 6 and 6. So once again, when we're thinking about totals, we want a higher total because we just started the game. So in this case, I'm going to multiply these two. So 6 times 6 is 36. If I chose to do the sum, I would only get to 12. The difference would get me to nothing. And the quotient would only get me to 1. So multiplying these to get a total of 36 would be the best idea. So then the second player places their game marker on the board. Okay, next I roll again. So I get a 1 and a 2. So looking at this, multiplying would only get me the answer of 2. So I am going to choose to add these 2 and get 3. For this turn, I get to add these to what I had previously. So in this case, I'm going to move this game marker. I'm going to add 3 to 9, and that's going to get me to 12. Okay, so next my partner is going to roll, and they luckily get 36. They get 2 6s again. So if I were that partner, I would probably multiply those again and get 36 again. So then I would be able to move my game marker to 72. So player 1 would go again. This time they get a 5 and a 6. So in this case, it would be best for this player to multiply those two to get 30 and add that to their 12 that they already have, moving this to 42. Player 2 goes again, and they get 6 and 6 again. Now, if they multiply 6 times 6 this time for a total of 36, they're going to end up over 100, and they would lose their turn. So the best thing to do here might be to add these two to get 12 and add that total to the 72. So they would end up being able to move theirs to 84. Right, so 5 and 2 is, I could add and get 7. I could multiply and get 10. And in this case, since I'm player 1 and I'm further behind, I'm going to go with 10. So I'm going to move my marker to 52. Okay, so player 2 is very lucky in this game, or could be unlucky depending on where I'm at. So they get 6 and 6 again. Once again, if I were to multiply these and add, I'd be over 100 and I'd lose my turn. So if I added these to 84, so I would get 12, and 84 plus 12 is going to give me 96. I'm going to be very close to 100, but I have to think about, is this a good strategy? Because of the fact that now I'm kind of limited on my numbers that I can roll to be able to move. Okay, so let's see. Player 1 goes, and they get 2 and 3. And in this case, they're still trying to get farther ahead. So 2 times 3 is 6. 52 plus 6 would be 58. Okay, so another 6 times 6. So if I added, I would get 12, and I can't move 12. Multiplied, I'd get 36. Definitely can't move that. If I subtracted, I would get 0, so that wouldn't make a difference. But if I divided the two, 6 divided by 6, I would get 1, so I could actually move up 1 for this turn. Okay, another 2 and 3, so 2 times 3 is going to be 6, and that would probably be the best way to go in this case. So it's 64. Okay, well. So this is starting to get interesting for player 2. However, they're kind of locked into doing a 1 again. Okay, so they're getting very close. Alright, so player 1 gets 1 and 6, so they can choose to multiply, add, divide, or subtract. In this case, we would add because we want to get further along. So we're going to add here. And when we get 7, we end up at 71. Again, 6 and 6, so this player moves up 1 more because they're going to choose to divide. Hopefully they'll be lucky enough to get this the next time. Okay, 6 and 1 again for player 1. So once again, we're going to add because that would get us further to where we need to be. Okay, so let's see if player 2 is lucky and gets what they need to get to 100. And they do. So player 2 gets another 6 and 6. And so they have officially moved to 100. And so player 2 is the winner. So this is how this game is played. At the end of menu, you will administer an exit ticket to check for growth between the whole group and small group instruction. Support students that continue to demonstrate a need of support through your district purchase state-approved intervention program. This is the end of Task 3.